Okay, very good. Then let us shift back over, and we're going to look at this whole issue of clash detection and how we can make that work within Navisworks fairly, well, hopefully pretty easily. To get ourselves started today, let's go ahead and out in the session 18 folder, you will find, that architectural model, that structural model, that MEP model. And if you don't already have them downloaded to your computer, you can download them again. I'm just going to bring them on into Revit so we can take a look at them. We'll take them over to Navisworks and play with them a little bit. So starting with Revit, let me go ahead and I'll just start by opening that architectural model. Okay, in this architectural model, you'll find an example of, something that looks like a very small restroom. Just a couple stalls, a couple sinks, things like that. You have a few more sinks to run and stalls to run, but it's kind of at that level in terms of what we're looking at. If we open up the structural model, let me open up that thing. And again, use these as examples of sort of what's expected here. In this model, you'll actually see that there are beams and beam systems. This model actually has K-braces in it too. It has a little bit of lateral bracing in there. I'm not asking you to do that. Ultimately, we would think about some sort of lateral support system, whether it's coming from a concrete shear core or some sort of bracing. But we'll simplify for right now. You don't necessarily have to worry about that. If you want to think about that and put in some bracing, go ahead. Knock yourself out in terms of really starting to think about how the building would be supported laterally too. And these guys down here, these are examples of, those little isolated footings down at the bottom of the columns. And placing those, that's really easy to do. For example, I'll knock that one out just so it's missing. Under the Systems or Structure tab, you'll find isolated footings. They choose a size of the footing. And I can even say just put it right at the column. And we'll put it right down in there. Oops. I say it's going to put it down there. You got to hit the finish. Okay, so that's kind of the level at which we're looking at for the structural. It's really just the columns, the beams. Those beam systems, those are, let's see if we can kind of hide those. I'll flip this back around. There's the major beams on the outside. The beam systems are those little groupings of beams that we put in there that are made up of a certain sort of type of element at a certain size. I shrunk them all up there again. Oh, it's going to play that game with me again. I'm going to see if I can cancel out of that. I made the mistake of updating to Windows 8.1 last night, which of course invites all sorts of trouble. Just in terms of Revit. I always have to convince Revit that I repair it after it's done to make it work. Okay. Over on the MEP side, let me go on over there. Open up that MEP model. And you'll see that within this one, we have that ductwork kind of running up into the ceiling there. Just to sort of understand where you want to be relative to the assignment, like this is an example of an air handler. And I can take that out just in terms of it not being that you don't need to include the air handler and ultimately resolve that. I'm sort of envisioning that you guys will run, the ducks will sort of go off to mystery land, okay, where interesting things will happen. Same thing over here in terms of the plumbing. Here it is routed on the two different sides. You see things coming to a riser and stuff like that. But go ahead and use these models as examples. If you're stuck and you're not quite sure what we have in mind, use these as models as examples because they really, this is kind of the level of detail we're looking for. And then, with that, there's that whole funny thing, could I go through grab all those things and say that I want to copy it and I want to paste it up to level 3. Okay, something's there double. I might have gotten the riser or something like that. But that's kind of the idea. It's just kind of getting them up to a different level like that. So get it done on one level, bring it on up. Okay, once you have these pieces together, you are going to go over to Navisworks. And let's open up Navisworks. As a desktop-based solution that construction folks like to work with, Navisworks is very good. Yeah, as Sarah sort of suggested, there is a cloud-based way of doing this called BIM 360 Glue, which has a very similar sort of capability. It's kind of like, oh, we can do rendering on the desktop, we can do it in the cloud. You can do coordination on your desktop, you can do it in the cloud. It's really kind of more almost a control issue about where people like to do it and whether you like to do it with files or whether you want to have a really dynamic, minute by minute, I make a change, we can coordinate and kind of see what the impact is. There's different ways of doing that. So here we are in Navisworks. Navisworks again it's that Swiss Army knife of it just opens things and pulls them together. So I like working with Navisworks. It is a little confusing though, I'll be the first to admit, because there's so many different things going on and panes that pop in from different sides. There are a lot of tools in here. So part of it is just like just clearing out the clutter about what it is you're going to focus on right now. But as we try to bring things together, it always starts with appending some files together. Let me go ahead and I'm going to bring in the architectural model. Say, okay, I can bring in the Revit file. I'm going to bring in the structural and the mechanical in there. You're going to see I actually have this little view open called the selection tree, which will show me the different models. Okay, let me switch that back over to another view of it, which is the standard view. Okay, is the architectural model. And under the architectural model, you can see there's a selection tree. I can select individual elements. So I can select everything on level 2 or level 3, or I can select on level 3 all the windows on level 3, or the walls on level 3, or things that are considered to be at the roof level. Just a way of selecting the different elements. We just need a way of kind of coordinating and keeping them together. Okay, I'm also going to go ahead and append in there that structural model. Now the structural model you may have a hard time seeing. It's kind of inside there. Yet, the easiest way for most people to spot it is those K-braces tend to show up. You can see them kind of poking through the windows. Okay, there's a little bit of structure in there. But again, if you want to, you can go through and hide anything. Let me go ahead and add in the MEP model and we'll show that. So in theory now I've brought in these 3 different models from 3 different design teams or from different members on your team that are all kind of coming together. Okay, all the information's here. It is in one big cohesive composite space right now. It may be hard to see everything because we've got all these layers that are kind of on top of each other. So if you want to expose anything, you can. Just rotate that around a little bit. So for example, if I just want to turn off the architectural model right now, I can hide it. And then I'll just see the structural model underneath it. If I want to turn off the structural model, I can hide that also. I'll just see the MEP systems under there. You can really turn on and turn off anything that's necessary just to give you a better view. You always have the ability to go through and do that. And you don't have to turn off the entire structural model. You could go ahead and say that, oh, I just want to go through and turn off the floors in the structural model. Or whatever category of thing it is that you have in. I turned them off on level 3. Let me turn them off on level 2. Okay, and that's just going to give me a little bit more control. What else is going on here? I think my view is currently being blocked by, it's probably a floor in the architectural model, and that would be hidden. Let's see what I have over here. Might be the ceilings that's blocking things. Might be the roof. Actually looks like it's the roof. and I've turned off everything. What is that thing? If you are unclear about what that is and you just want to turn it off that way, you can finally just choose it and see what it is. Oh, it's the analytical floors. Well, how interesting. I don't really want to see those at all. Analytical floors are the floors that are being used for the structural analysis. They're kind of like single plane representations of the floors. Okay, so now I'm sort of looking at, a little bit more of how things are working together. Let me go ahead and I'm going to turn back on that roof framing in the structural model, because the things up at the upper level turn off the floor at the roof level. Okay, you can start to actually see, we're going to start having some problems here, where we can start to see, we got some ductwork, we got some framing, it's all going to start conflicting with each other. There's a problem here in terms of what's going on, and we need to go through and resolve that. So we can go through and just start working with things now. We don't need to use the clash detector. The clash detector is really just a tool to help us find interferences. But interference is an interference. If you find it, no worries. You can go ahead and act on it anyway. As we pull these models together and kind of create the composite model, we often want to go through and save our work, because if we've pulled a bunch of things together from different sources and we've had to do a transform, we had to shift anything around to put them all together and make it work right, we would like to actually sort of save the set of models and how they're intersecting with each other right now as something that we could come back to later, tomorrow, just really, really easily, so we don't have to kind of keep on appending every time. So to do that, what we tend to do is actually go under the application menu and say save, and I'll say save as. I got a couple different choices here. Let me tell you about the choices. We have a Navisworks File Set. Let me tell you what that is. A Navisworks File Set is really, it's the collection of the different files that need to come together, but it's links to the files. So it's, okay, I'm going to pull an architectural model, a mechanical, structural all together. I'm going to link to those files, but they're still going to be external to where I am right now. Okay, but the information about how I got them together, and any transformations I need to make, and anything I do with them within Navisworks is all stored as part of that file set. The important thing, though, is the files aren't actually there. The model files aren't there. They're still external. Okay? And the nice thing about file sets is we sort of store our work in Navisworks, but if the architect decides to change the architectural model, my set can open up the newest version of the architectural model so that I can then see what the changes are and verify, things are improving if we're solving some of the clashes. So we tend to actually work more than anything in file sets. The problem with file sets you need to know about is file sets have the external dependency on the links. So if the links get separated, you may need to go ahead and find the link and kind of bring it back in there. But they're nice dynamic links. Okay, files, yes?
For the changes that you make in Navisworks, do they automatically update the modules that you've appended?
The interesting thing is you can't actually change the models. You can transform them, but you can't actually, for example, change the locations of the beams and the ducts in Navisworks. What you do is you actually have to go back over to the Revit file, change it there, and then bring it back in. Okay, interesting point. Because it's a control thing. It really gets down to this issue that, you as the construction coordinator, I don't want to let you change my structural elements. You got to ask me to change them since I'm liable for them. Okay, but very interesting, because you want to think about changing. You can do little temporary transforms, and people do that. Okay, but really the dominating document is the original model. Okay, so file sets are good because they stay alive and dynamic, but you have to kind of hang on to all the different file pieces. The other thing we tend to save things, though, is actually called an NWD file, like a Navisworks document. Let me talk about that. A Navisworks document is a completely transportable, self-contained set of information, including the files. So the Navisworks document actually copies all the model data into it, okay, as a snapshot, as of today. Today at 9:43 a.m., this was the status of the file and everything we're working on it, which is really, really good for making a snapshot that I can go back to and refer to 3 weeks from now about what was the status on Thursday at 9:43 a.m. and do a comparison. Okay, but it's a static snapshot. So you have file links, you have static snapshots. Each have sort of a different applicability. As a working team, I tend to work with a file link system so it stays up to date. If I want to give something to you, I will probably give you a document that has the current snapshot and everything self-contained so you can work with it, but you can't change anything. You can sort of look, but can't really make any difference or changes to it. So watch out for that. When people give you things, be aware of when they're sharing things with you, are they giving you the Navisworks document or the file set? The document's kind of locked in time. You don't have much control. The file set, if they give you the original files, you have much more ability to kind of change things. Okay, so that's the big rundown on those. I'm going to save them as a file set right now, so it'll stay dynamic. If I actually choose the right option. Okay, and I'll say, so this is saved away. Later on, I can just open up my Navisworks coordination set document. Okay, and the fact that I've linked them all together will be saved for me. I can get right back in here. Okay, I have these things. They're looking a little bit messy. I would like a little help in terms of understanding where my clashes are and stuff like that. So what I am going to do is shift my focus a little bit. I'm going to open up a different tool called the Clash Detective. I'm actually going to hide the file selection tree over. I'm just going to kind of close it up so we can't see it right now. I can open it up again. I can pin it if I always want to see it, but it's kind of in this nice collapsible form. Okay, but again, one of the things I always struggle with Navisworks is there are so many different windows and panes that pop up. It's trying to remember which window you're looking in. Okay, I am going to open up on the Home tab one of the big tools we're going to work with today called Clash Detective. It looks for interferences. And let's talk about how it works. The idea of the Clash Detective is you set up different tests of things that you want to compare to each other. Okay, so by default, when you start out, everything's all grayed out. We're going to say add a test to it. And I'm going to add a test to this thing, and I'm going to call it, for example, beams versus ducts. Now, I can create a lot of different tests. There's so much stuff you can do. In fact, let me create another test. Okay. Entire structure versus mechanical. Okay, so you can create a bunch of different tests for things you want to test. On a typical building project, there really are thousands of pieces out there, a lot of things that need to be tested. And you want to start actually thinking about specific pairs of things that you want to look for different types of interferences. If I just intersect the entire model, you get a lot of stuff, including a lot of what I'll call false positives, just things that are probably okay, just a little bit sloppy about the way we've modeled things. But let me show you what that would look like. I'll fill out entire structure versus mechanical. And to do that, for example, I can just choose the structural model over here and the MEP model over there. So I'm just choosing things at a really high level I might want to run against each other. There's a different type of tests. There's a hard test. The hard test is really if there really is a physical clash. And you can specify really what the tolerance is. You can get to that whole issue. Are things allowed to sort of be next to each other? Can they overlap just a little? Or how much overlap does it have to be before you really consider it a problem? How many millimeters really makes it a concern? Because, again, there's sloppiness in the way we model. Sometimes things just sort of brush up against each other and it's actually okay. I'll leave it fairly conservative right now. I'll just run the test. You'll see that at a really high level, just clashing the mechanical versus the structural, there's 72 different clashes in there. And in those different clashes, let's go ahead and kind of pull them up a little bit. There's a list of the different clashes here. For example, clash number 1, you can sort of see it highlighted over here. We can control what happens in terms of highlighting and whether we want to see the clashes. Let's see if I can pull that up. Okay, clash number 3 is down here. You'll see that a lot of these clashes are just, well, they're interesting or uninteresting. In this case, what we got? We have sort of a structural column hitting the acoustical ceiling. Now, that's an example we'll call a false positive. We really don't care about that so much. That'll get fixed. Someone, when they put in the ceiling, will box it out around the column. We could go through and model that to avoid all that, which would take an awful lot of work, or we could just sort of live with that. Okay, so that's an example of one that I'm not so concerned about. What I can do, though, is actually go through and find different things. For example, I'm probably going to find a lot of things that are interacting with the ceiling. And if I want to, I can do something called group the clashes involving this item. That's a really quick way of saying, hey, anything that's involving the ceiling, let me just put it into a category so that I can grab them all right off the top. Because it's going to probably be, every column is probably going to hit that ceiling and create an issue for me. So I'll say, let me group those. Okay, so now I have, I'll call this like ceiling 1. And you'll see there's a bunch of clashes in here that are in that group right now. So clash 1, all the way through 30 or something like that, or kind of in this category of just things involving that ceiling. So those aren't too bad. In terms of what to do with them, right now they're considered new clashes. I can say that, I've reviewed them, I've approved them, I've resolved them, I can assign them to someone. Let me say that those, I've reviewed them. I'm just going to put them in that category. Okay, and then I'm not going to worry about them so much anymore. Kind of wonder why it's not kind of showing up there. Okay, one thing's reviewed over there. All those things are in that category. They're kind of better off. Okay, as you're going through and working, we could go through and keep on paring down this list, but probably a better way to do it is actually go through and do a more limited test, something that only has the things in it that you're actually concerned of. So what I'll do is, as opposed to going for the entire kind of system of the structural versus the mechanical, let me go through and see if I can refine this a little bit to be what I want. So for example, on the structural model, if what I really want to get is just, for example, the structural framing, okay, that being the beams and the beam systems, and I can look at different levels. I can say at level 2 and at level 3. Let me grab that one too. See if I can do this right. Windows and I fight with each other. I want it to be a control click. There, control click. Okay, now I got the structural framing at level 2, level 3. Although I'm going to go through and also choose the roof because there's this funny notion, and I always get confused about it. I believe the roof or the ceiling framing on the 3rd floor is considered to belong to the roof as opposed to actually belonging to level 3. So I got structural framing at 3 levels. Okay, let me come on over here, and on the MEP side, I can just do that with the entire MEP model. Or I can go through and say, oh, let me just go for a specific thing like, let's just go for the ducts and the duct fittings, something like that. But you can sort of subset this a little bit. Try and be very specific about what it is you want. This will be saved as part of that test. Okay. When we go through and run this test, oops, looks like I got it in the wrong category. I wanted you to be you. Okay, select again. Structural framing, framing. Okay, framing, control versus MEP model on this side. It's only mechanical equipment on the roof, so it must be on the 3rd level. Okay, I run those things against each other. Okay, I got 32 issues. Now, what's better about this list than the other list? This list is actually only sort of framing things versus duct things. It's a little bit better in terms of, being things that I really want to consider. So for example, the ceilings aren't going to be in the list right now. So any clash I go through and choose over here, as we choose, you'll see that we sort of see a listing down here of what the elements are. So it's a particular rectangular duct versus a particular beam over here. Over here on the side, you actually sort of get a highlighted view of where it is in the model right now. It sort of tells you where the grid location is. As we go zipping on down there, you'll see we have some big problems in terms of some of these different things. Now, once you've identified this whole list of problems, okay, one thing you might want to do is create a report so that you can share this with people and start making a hit list of things that you want to knock off. So in the assignment, we're asking you to produce a report that just shows what some of your initial clashes are, because you want to sort of understand what the baseline is, and then you're going to fix them. Okay, so to create that report, there's actually a tool right here. That's actually exporting the clash test. Hang on. I got to always find where they move things to me. It's the report tabs right there now. Okay. We can choose what we want to include, you know, what kind of information about all those things. I'll do it for the current test. You can decide whether you want to include all the different clashes, or maybe we'll take out the ones that are already resolved, because you know those we don't really care about having on the list anymore. Even the ones that are approved, maybe we'll take those out, or you can include them. Depends on really what you want to have in the report. But the idea is you can create an HTML format report. Let me write the report. I'll put that over just in my documents right now. So this is what you'll be doing. Downloads, desktop. Let's put it on the desktop for now. It'll create a report for me. Okay, once it's created that report, I can go on out there. There's actually a file as well as a bunch of images that are related to it. So what I'm going to do is actually just open this thing. I'll open it in Chrome. It's just an HTML file. And you'll see it's all kind of hanging around over here in terms of, for each of those different clashes, really where it is, what the degree of the clash is, what the element numbers are. Notice every individual element in Revit has an ID number. You know, that duct was, that piece of structural framing does. They're all in there. So what I'd love to do is, with this report, just go ahead and save it as a PDF. And the reason I'm saving it as a PDF is it'll be a little bit easier for someone else to read it, as opposed to looking at it as HTML. So within here, we'll need to do some sort of printing. And I'm going to just print it to, I have a little PDF writer called Primo PDF, but anything will work. Okay, that'll just save that away. So for the part where we say do the initial clash test, it's that run the clash test just exactly the way it is, no fixing. Okay, run the clash test. Let's see how many clashes you had initially. Let me kind of create this thing on the desktop. Okay. So I have a nice PDF now that summarizes that. Oh, it's going to complain at me because I'm on the Mac and the PC. Well, whatever. I'll leave that alone for now. Okay. So start by just giving you the initial clash report. Once you have that initial clash report, let's go back and think what we can do with these clashes. Because you got all these clashes kind of hanging around in here. They got this big old list of all these different clashes on the results tab. Okay. We'd actually like to go through and start fixing them. So here's where it gets kind of interesting. We can go ahead and take that clash report, okay, and hand it off to someone and say, great, here are all the locations, go ahead and start fixing these things, and someone can do it that way. But if you actually have access to the Revit models that were used and are being clashed against each other, we can actually use something that it has built in, what's it called? I switch between products, so switchback, which lets you then go through and rotate through and actually find those original elements. Okay, so let's do this. Let's go ahead and break now for 5. Come on back, and when we do come on back, we'll show you how you use the switchback feature to actually go through and change the things over in the Revit model and bring it back in to Navisworks. So you can fix things and dynamically change things, bring them back in real quickly.